දැන් හරිද නෝකෙනෙක්?
පහක් කිලෝ පාටස. නාස්තිස් කීයද කියලා ඒව දාලා නැහැ. මේව දාලා නැහැ. මේ ඔන්ලයින් දාන්න කියයි දැන් ඊපස් දැන් ඊළඟ මාසෙ. අපිට තමයි. මේව දැන් ලොකුවම ලැබි හටයයි මේ ටික. මේ කට්ටල ටික. මම නේ ලොකුවම දන්නව නේද? කියන්න ඕන කොහොමද?
හරිම ලස්සන.
Mana ya pisu. Right, okay. Students, can you all hear me?
Yes.
Can you hear me?
Yes, sir.
Yes, sir.
Right, okay. Right. So today is the first theory session of chemistry class, right? So first of all, good evening for all of you. And so how are you? All doing good? How is your use chat box to give answers, okay? Because I don't want to interrupt others. So therefore, don't need you don't have to speak for the mic. So therefore, put your answers in the chat box. Normally in my theory classes, I won't allow students to speak. So always keep your mic muted and make sure to put your doubts or anything. So your answers in the chat box, right? So that is the way in my chemistry theory online theory class, right? Okay, right. So then let's start the lesson. So today we have to start the lesson. And last week morning we conducted our introduction session for the subject, and I told you what are the things we have to learn. So what are the parts you have to go by studying chemistry, and what is the syllabus, and what is chemistry. So everything around this subject, the things that are related to this subject, I explained in the introduction session, right? So I uploaded the recording also. So I think all of you, those who missed the session, I think you went through the recording, right? So if you didn't went through the recording, go through the recordings, tell me, I'll upload the session again, right? Okay, right. So let's go for the lesson. So students, remember, I told you that in our syllabus, there are 14 units to discuss, right? I told you our first plan is to cover the first 3 units, general chemistry, right? We know that general chemistry can be divided into three units. I told you that one, right? The chemistry syllabus, actually, we have so many parts: general chemistry, inorganic chemistry, organic chemistry, physical chemistry. At last, we are going to discuss industrial and environmental chemistry. If we want, we can categorize that one under inorganic chemistry. So under the general chemistry, we have to discuss about 3 units: unit number 1, unit number 2, and unit number 3. So these are the 3 units, and I told you that first of all we have to prepare for our grade 12 first term test. So this is our target, grade 12 first term test. I'm preparing you for this target first of all, right? So what are the things you have to learn under the first unit? The topic is actually atomic structure, and the second unit is structure and bonding. Students, as I mentioned you, please mute your microphones, mic, okay? Then we can conduct this class more effectively, right? If you have any doubts, put your doubts in the chat box. I'm going to answer for all of your questions, right? Structure and bonding, and the unit number 3 is chemical calculations, right? So these are the 3 units that we have to cover before the first term test, right? So today we are going to start our first unit, unit number 1. What is the unit number 1? Atomic structure. Atomic structure. So this is our first unit, atomic structure. Okay, right. Now I think I have posted the first batch of the tutorials for some of you. Can you please raise your hand who received the tutorials? Can you please raise your hand who received the tutorials? Okay, right. Good. Some of you have received the tutorials, no? Okay, good, right. Okay, others doesn't matter. Don't worry. Your tutorials, you will get that one very soon. For the students, those who gave the you addressed your details later, so they also get the tutorials later, right? That means the මෙහෙමයි. So ඔයගලන්ගේ සමහරක් කට්ටිය ටිකක් පරක් වෙලා තමයි address ටික දුන්නේ. එතකොට ඔයගලන්ට පොඩ්ඩක් tute එක delay වෙන්න පුළුවන්. දැන් ඔය මේ මුලින්ම මේ address ටික දුන්න කට්ටියට මේ සතිය අග වගේ. එහෙම නැත්නම් සමුද වගේ හම්බෙයි. But for others also, before next class, actually, you will get the tutorials, right? But don't worry, students, without the tutorial, we can conduct the class today because when I'm conducting for 25 batch also, කලින් අවුරුද්දෙත් අපි class එක කරද්දි පළවෙනි day එක අපි ගාව tute එක නැතුව තමයි අපි කරේ ඒ session එක. So today also I'm going to conduct the session without the tutorial, right? Doesn't matter. So take out a book and you have to write down everything with me. I'm also going to write down everything on the whiteboard. When you get the tutorial, what you have to do, I'm going to upload the note, my handwritten note to the WhatsApp group, and you have to complete the tutorial, right? So today in class, remember, you have to write, you have to listen, you have to think. Right? You have to write a note with me. You have to listen very carefully what I'm going to teach you today, and you have to think what are these things. And if you have any questions, you can raise your questions. You can put your questions in the chat box and let's discuss what are the things we have to sort out there, right? So don't worry if you don't have the tutorial. Take it easy. So today first day, doesn't matter. From the next week onwards, you will have the tutorial, right? Okay. Right. So ladies and gentlemen, let's move for the first unit number 1, atomic structure, right? So before we move for the lesson, let's see what is the content. What are the things we have to learn under this topic, right? Okay, so take out your books and write down the topic. Unit number 1, atomic structure, content. Quickly with me, Taggala. We don't have time to waste. Okay, so therefore quickly with me, you have to write down. And I'm going to explain everything that we have to discuss today. So first topic that we have to discuss under the atomic structure is atomic theory. Second topic, the first topic that we are going to discuss is atomic theory. If you have the tutorial, in the page number 1, I have given you space to write down the content. At there you can write down. If you don't have the tutorial, don't worry. Take out a book or piece of papers and write down everything that I'm going to teach you here, right? If you don't have the tutorial, take out your books and write down. After you get the tutorial, you can complete the tutorial. If you have the tutorial, you can write down everything on the tutorial, okay? Because content is also, I have given you space to write down the content in the tutorial. Turn to the page number 1. Right, okay. So this is the first topic that we are going to discuss, and we are going to cover this topic today. What is atomic theory and what is the starting point of the term atom, how that this term atom came into the world, right? So we are going to discuss about that one here. And the next one is discovery of subatomic particles. So this is the main topic that we have to discuss today, particles. I hope to discuss electrons with you. We know that there are 3 subatomic particles, right? What are the 3 subatomic particles? Electrons, protons, neutrons, right? Don't write down the names. Now practice with the symbols. So what are these? -1, 0, 1, 1, 0, 1. I'll let you know about that one. Now you have to deal with these units, electrons, protons, neutrons. Today we are going to learn how they have found this electron, okay? So that story, we have to learn 3 stories, 3 main stories in the first unit. How they discovered electron, how they discovered proton, and what is the story of neutron, right? So that's what we are going to learn under discovery of subatomic particles. Got it? So this is the second topic that we have to discuss under atomic structure, right? Okay. So the third topic that we have to discuss is atomic models. Right? Remember, students, I'm planning to discuss 5 atomic models with you. Actually, in our syllabus, there are only 4 atomic models. The first one is John Dalton's golf ball model, and the second one is Thomson's plum pudding model, and the third one is Rutherford's nucleus model, and the fourth one is Bohr's energy level model, and the fifth one is quantum model. Quantum model is not mentioned in our syllabus, but I'm going to give you a brief idea, a short idea about what is quantum, right? When we are discussing about the orbitals in detail, we are going to discuss about what is this quantum model and what is for how they discover this, right? Okay. So atomic models, right? Because after finding these three subatomic particles, we should know that how these three subatomic particles are arranged in an atom. After finding these three subatomic particles, we know that what are the three main subatomic particles? Electron, proton, neutron. So then there was a question raised that how these three particles are arranged in an atom. That's how atomic models topic came into the play, right? So there are many scientists involved in this topic. We are going to discuss that one. So the next one, atomic number, mass number, and isotopes. Isotopes also actually very important topic. We have to do some calculations also, right? Isotopes. Number 5. I want to tell you something like this. In isotope, remember students, we have to do some small calculations. When we go for the electromagnetic radiations, we have to do the calculations using equal h nu equation, equal hc over lambda. Again, මේ වගේ equations පාවිච්චි කරලා අපිට ගණන් හදන්න තියෙනවා. So don't worry. You are going to learn what is this E, H, C and everything. You are going to learn these things. So we have to do some calculations. So for that one, I'm going to do a separate logarithm session with you, right? Because in your O-level time, you have learned logarithm. But anyhow, by assuming that you don't know anything related to the logarithms, I'm going to teach you a logarithm session, a separate session. I'm going to take that one before this calculation topic, right? So therefore, keep that in your mind. And later you will have, addition to the tutorial, you will have this kind of logbook printed by me. Actually, this is for 25 batch, right? And a file cover is also printed ongoing. So therefore, you will receive those things also, right? So keep that in your mind that in isotopes, we have to do some calculations. Next one, duality nature of electrons. Duality nature of electrons. Number 6, quantum theory. Quantum theory. Quantum theory, we are only discussing few things, not depth. We are not going for the depth because quantum is actually very complicated part. So many mathematical stuffs are there. So therefore, we are not going to discuss about those things. A simple brief introduction about the quantum theory, right? Right. Next one, location of electron, very, very important, right? You know about electron, you know how found the electron, who found the electron, but do you know what is the exact location of electron? We are going to discuss about that one in this topic, right? Location of an electron. Number 8, electromagnetic radiations. Electromagnetic radiations. Electromagnetic radiations. Under the electromagnetic radiations only, as I mentioned you, we are going to discuss about this calculations. We have to do some calculations there, right? So don't worry, students. I'm going to teach you a separate logarithm session that is essential, that is necessary for the chemistry calculations. As I told you, we have a separate part in chemistry known as physical chemistry. In physical chemistry part, we have to do calculations, right? කම්මැලි වෙන්නේ නැතුව ගණන් හදන්න ඕන chemistry වලත්. So you are going to do that one with me. Before that, at the beginning of the first minute, we are going to practice you for the calculations, right? Okay. When I'm conducting that session, I will let you know about that one. Let's have a discussion, right? Okay. So did you write down these things also quickly? We have 7 more topics. Are we done? Put your answer in the chat box. Yes or no? Yes, good. Quickly, yeah. So first day, we are going to do the works. Now, as I mentioned you in the first introduction session, I told you that mentally all of you should be prepared. Dogol mentally last ida. Are you doing A level low, O level? Now you are doing A level lah. වැඩිපුර වැඩ කරන්න ඕනේ කම්මැලි වෙන්න හොඳ නැහැ. So you have lot of targets, right? So therefore keep that in your mind. Huh? Topic number 9, atomic spectra. Very, very interesting. This is very, very interesting topic. We are going to discuss about the hydrogen emission spectrum. What is emission spectrum? What is spectrum? What are the electromagnetic spectrum? So everything we are going to discuss about this topic, in this topic, right? I'm eagerly waiting to discuss these things with you. It will be very interesting. Next one is, yes, as I mentioned you, we are separately discussing about atomic hydrogen emission spectrum. Atomic hydrogen emission spectrum is our next topic. Number 11, quickly with me, sub-energy level concept. Sub-energy level concept. I told you once that in your O-level time, you have learned that electrons are located in energy levels, like KLMN, subshells, right? So here we are going to discuss about sub-energy levels. That means these energy levels are again going to split into what? Sub-energy levels. S, P, D, F, likewise, sub-energy levels are there. So under this one, we are going to learn about Seaman effect, Stark effect, everything. So very easy things. So those things are very easy. So therefore, don't worry. Sub-energy level concept. So the 12th one is atomic orbitals. Atomic orbitals. Let's see what does mean by atomic orbitals when we go for the topic, right? Then the next one, 13. Electron configuration. Yes, very, very important. Electron configuration, right? In your O-level time, you have learned electron configuration like this. If I consider sodium electron configuration is 281. This is the way you learn. But in your A-level time, how you are going to learn, how you are going to write down the electron configuration? You are going to write down the electron configuration as 1s2, 2s2, 2p6, 3s1, right? So this is related to the sub-energy level concepts. So these are sub-energy level students, right? You haven't learned these things in your O-level time, ne? Now in A-level, we are going to learn about these things in detail. I'll teach you how to write down these things. Very easy and very interesting. Okay, right. Now, electron configuration. After electron configuration, we are going to discuss about, yes, quantum numbers. Quantum numbers. Quantum numbers is like your just like your address, right? So the electron is located in energy level, sub-energy level, orbital, which type of electron, right? Your city, your village, your street, your house number. So likewise, quantum numbers is explain the, what is explaining? The address of electron. අපි කතා කරනවා electrons වල address එක. අපේ electrons වලට ලියුම් ලියවන්න යන්නේ quantum numbers ඉගෙනගෙන, right? So the next topic, the last topic is periodic trends. Under the periodic trends, we are going to discuss about, remember students, first ionization energy, atomic radius, electron gain energy, electronegativity, like properties we are going to discuss under periodic trends. And you and me, all of you, all of us, we are going to draw the periodic table here. I'm going to draw the periodic table in this whiteboard with you, and you're also going to draw the periodic table in your tutorial, right? When we are writing the electron configuration, you are going to write down the electron configuration from hydrogen to barium. Now you may have a question like this, sir, do we need to remember the periodic table? Don't you have a question like that? So do we need to remember the periodic table? What do you think? Right. I'll tell you like this. It's not about memorizing or studying the periodic table. You have to analyze the periodic table, right? By writing electron configuration from hydrogen to barium, barium is 56, automatically you will remember up to barium. I'm very sure that after writing these electron configurations, you will be able to remember the first 56 elements in the periodic table. But we know that how many elements are there in the periodic table? 118. So the remaining one, you don't have to remember. I'm not going to force you, right? But if you want to memorize this one, yes, of course, you can memorize that one, right? Because there are two periods are there actually in the periodic table that we are not concerning much. Lanthanide series and the actinide series, right? In the periodic table, at the bottom of the periodic table, we have lanthanide and actinide. So we are not going to discuss about those things in here. If you want to learn them, you go for the university to learn chemistry as a subject. Understood? So therefore, at least you have to remember first 56 elements in the periodic table. We have a plan for that. So those are the things we are going to learn under periodic tables. So students, in the atomic structure first today, we have subtopics. How many subtopics we have? 15 subtopics. But don't think that easily we can finish these things. We are going to discuss about each and every subtopic perfectly. Hari, metanta danena vidiyata thama ugannanne. Right? So it's your responsibility to learn this one very honestly. I'm expecting your honesty. And if you have any doubts, let's discuss these doubts in the class. Okay? Are we done? So these are the 15 subtopics. Quickly finish it. Done. Right. Okay, now if you have the tutorial, you can see that in the page number 2, I have given you that. Yes. By the way, if you have any doubts, put your doubts in the chat box. Huh? I can see that. So is the periodic table given in the exam for the part 1? Yes, students. In part 1, part 2, in both the exam, they are giving the periodic table a printed one. But don't depend on that, right? So as a student, as a chemistry student, you should be able to remember the elements. What are the elements that we are frequently using? ඒකට ඔයගලන්ට පොඩි idea එකක් එනවා සාමාන්‍ය ඉගෙන ගත්තට පස්සේ මොන මොන elements ද සාමාන්‍ය මතක තියාගන්න කියලා you know that, right? So therefore anyway they are giving the periodic table, but for my students I'm always recommending that at least you have to remember 56 elements in the periodic table, right? Keep that in your mind. But anyway, in the examination they will provide you periodic table. It's a must. But my advice is don't depend on that. Can you believe this government? Can you believe this educational department? Neither. Believe it. So therefore, remember that. Right. So students, what is chemistry? I have discussed this one in the introduction session, but anyhow, we are going to write down, we are going to put this one in our note. Right. Now I need your answers because most of you know this one. What is chemistry? I need simple idea. I need only a simple definition. What is chemistry? What are the things we are going to learn under chemistry? Yes. Very good. Yes, I have a lot of answers. Study of chemicals, study of properties and behavior of matter, study of matter and energy associated around it. Yes. Study of matter and energy. Yes, yes, yes. Very good, very good. Right, very good. Remember, students, I told you that once in the introduction session. Doesn't matter, I'm going to revise those things again because we are not going to learn these things again. These things are very simple. Everything around us, let me take universe. This universe can be divided into 2 parts. What are the 2 parts? Matter and the energy. Right? So matter means actually physical things. Physical things means you can see that one. You can touch it. You can hear that one. What about energy? Non-physical things. Right? Non-physical things means you can't hear them. You can't touch them. So those are the non-physical things. So chemistry means simply we can say that study of matter. We are going to discuss about energy mainly in physics, right? Subject like physics, actually in that subject we are going to discuss about this energy more, right? So we have in the physics, in the first unit, I think second unit, you have a part known as work power energy. We are going to discuss about energy separately there. But in chemistry, we are going to discuss about the matter, how the things are made. If I take a water bottle, inside the water bottle, water molecules are there. Water molecules are made by what? What are the elements? What are the atoms? What are the subatomic particles inside that atom? If I take this marker pen, what are the particles made by this actually marker pen? Ink is there. How that ink is made, right? So everything we are going to discuss under matter, physical things. But I told you that, remember, there is a strong connection between matter and the energy. In the introduction session, I explained you endothermic reactions, exothermic reactions. Can you remember? When sodium hydroxide is reacting with HCl, it's releasing energy outside. When ammonium chloride is dissolving in water, it absorbs the energy from the outside. Exothermic, endothermic. Releases energy outside, absorbing the energy from outside. So matter and the energy has a strong connection, strong relationship. So not only matter, but we are going to discuss about the relationship between matter and energy. So therefore, students, we can define what is chemistry. If you are asked what is chemistry, then hitanda O level da O level කරන නාගි කෙනෙක් හරි මල්ලි කෙනෙක් ඇවිල්ලා අහනවා brother sister අයියාගේ මොකද්ද chemistry කියන්නේ? Then you have to explain it properly. ළඟට අඩ ගහලා කියන්න. අදින් පස්සේ, right? What is chemistry? Chemistry is study of matter and the energy associated with it. Can you understand? Right. Quickly write down with me. Write on the topic, what is chemistry? And with me, quickly. The things in universe, quickly, with me, can be classified so this is our specialty of our chemistry class, students, right? I'm going to write down everything with you. Unnecessary things will be printed on the tutorial. Everything which is necessary, I'm going to discuss. I'm going to write down everything with you on the whiteboard, and you are going to write down that one after you get the tutorial. Now today, take out your writing books and write with me. කම්මැලි වෙන්නේ නැතුව ලියන්න. chemistry වල වැදගත්ම දේ තමයි what is the important thing? Chemistry not, right? Most of the students are suffering by not having a proper note for chemistry. So don't let it happen that for you from the beginning. Continue a proper note. The things in universe can be classified into two main categories. As matter and energy. Matter is anything that has mass and takes up space, while energy is the ability to do work or cause change. All right. So this is what we discuss here. Quickly write down with me. Cause change. Take out the red color pen quickly. Take out the red color pen, write down. Chemistry is the study of matter and the energy associated with that matter? Quickly complete the note. ඔයගලන්ට ටික වෙලාවක් යද්දි තේරෙයි ඔයගලන්ට ටිකක් ෆිසිකල් ක්ලාස් එකකින් ඉන්නා වගේ බොඩි ෆීල් එකක් එයි. මේ වගේ නෝට් ලියද්දි ටියුටෝරියල්ස් ෆීල් කරන්න. Right, quickly. Done, ne? Quickly, yeah. The things in universe can be classified into two main categories as matter and the energy. Matter is anything that has mass and takes up space, while the energy is the ability to do work or cause change. Therefore, chemistry is the study of matter and the energy associated with that matter. Right. Okay, shall I erase this one? Are we done? Done. Very good. Okay, students, after this definition, I'll give you, have given you small space in the tutorial. So others, since you have writing book, you can write down the classification quickly. Yeah? This classification you have learned in your O-level time. So nothing changes, same thing we are going to discuss. Remember, when you consider matter, we can divide matter into two parts, right? Depending on their chemical composition. Pure substances and mixtures, right? So when you consider pure substances, again, pure substances can be divided into two parts. What are they? Elements and compounds, right? So what is it again? Matter can be divided into two parts, pure substances. What does it mean by pure substances? Completely the same element, pure substances. The same compound or same element. But when you consider mixture, two different things are there. What are the examples for elements? We can consider a few examples: hydrogen, oxygen, nitrogen, helium, sodium. Elements. What are the compounds? We can consider water, H2O, ammonia, glucose, C6H12O6, right? These are the compounds. And mixtures we can divide into two parts again. The first one is homogeneous mixtures. And what is the second part? Second one is heterogeneous mixtures. Right? Remember, students, homogeneous mixtures means actually the chemical composition is what? Uniform. Throughout the mixture, the chemical composition is what? Uniform. That kind of a mixture is known as homogeneous mixtures. What are the examples? We can consider, what about salt solution, right? When you dissolve salt in water, salt solution is homogeneous mixture because chemical composition is uniform in the mixture. And then we can consider about sugar solution, right? So when you dissolve sugar in water, especially in hot water, right? Then we can consider that one as homogeneous mixture, right? What about heterogeneous mixtures? For example, I'm going to take rice and sand together, right? So that is actually heterogeneous. You can see that the chemical composition is not uniform in the mixture. But if you consider salt solution, after dissolving salt perfectly in the solution, can you separate that one from the physical nature? No, we can't do that one, right? So this is actually how we can matter depending on their chemical composition, right? So therefore, let me write down according to chemical composition. Chemical composition. You have learned this one, right? This classification, same thing you have learned in your level time, right? Remember, students, another classification is according to physical nature. According to physical nature. According to physical nature, we can divide into three parts. Can anyone tell me that one? Right? We can divide matter according to its physical nature. What are the three parts? Anyone? Yes, very good, very good. Yes. Solid, liquid, and gases. Got it? Solids, liquids, and gases. So later we are going to discuss about aqueous, plasma. In biology, especially, you will learn about these things, right? But mainly we consider only these three: solid, liquid, and gases. Got it? So this is the classification that you are learning in O level. But here also, nothing different. Same thing, right? Quickly write down this one. In the tutorial, if you have the tutorial, after that paragraph, what is chemistry, I have given you small space. In that space, quickly summarize this one. Today I want to finish atomic theory and the cathode ray experiment. So therefore, so is saline homogeneous mixture? Yes, exactly. So it's like sole solution. Saline is also. Can you separate the things in the saline mixture? Again, a saline solution water. I think you can't do that one, right? So therefore, saline also homogeneous mixture. Very good. Huh? If you have any doubts, likewise, you have to put your doubts in the chat box. This is the way of our class. All of you should be engaged. Right? You must learn by questioning. That's the proper way. And one more thing, students, from the beginning, I'm telling you that don't try to memorize. Right? The first thing is learn these things properly. In the class, you have to think about these things, listen to this one very carefully. If you have any doubts, clear them. That's all. Right? And I'm recommending you to attend for the live classes daily. For every student, every batch, I'm telling this one. Every day we are telling. But for you also, we are telling that one. Try to attend for the live classes. Right? In case if you cannot attend that one for a fair reason, doesn't matter. For example, now just imagine you are suffering with a high fever, then you can't attend for that one. So therefore, doesn't matter. Right? But don't depend on the recordings. Huh? So that is my advice. But in case if you cannot attend for that one, for my theory students, anytime recordings are available. ඔයගලන්ට දැන් 25 කට්ටියට තාම පළවෙනි යුනිට් එකේ recordings තාම බල ඉන්න කට්ටිය ඉන්නේ. හරි? මොකද අර සමහර කට්ටිය පරක් වෙලා ජොයින් වෙලා ආපු කට්ටිය අර එහෙමත් ඉන්නවනේ. So therefore nothing to worry. So someone has unmuted and is disturbing. Who is that? Can you please mute your microphone? Can you please mute your microphone? Now, okay, ne? Can you tell me who is that? Right, okay. Right, okay. Right, don't think about that one, okay? Right, it's okay. So, Abdul Rahman, please mute your mic. Please don't interrupt others, okay? Because we are discussing other things are very important the first day. So therefore, please mute your microphone, right? A kind request. Next one, right? So this is the classification. Now, the next topic is atomic theory of matter. Go for the page number 3, those who have the tutorial, the atomic theory of matter. The atomic theory of matter. Right. Shall I erase this one? Are we done with this? Classification? Done. Good. Right. So this is the beginning of what? Beginning of atom. Remember, students, now think about the ancient people actually. Ancient people are not like us. enemy. Yeah, this is the first theory class for 26 bell. Yes, Aisha. And we conducted an introduction session. I'll give you introduction session if you want to know about the subject, right? Okay. So, ladies and gentlemen, listen to this one very carefully, yeah, quickly. The atomic theory of matter. Now, ancient people are not like us. Why? They had a lot of time. They didn't have money like us, but they had a lot of time. They had a lot of time to think. That's why so many peoples, so many scientists, right? So many philosophers, so many mathematicians, so many chemists, so many physicists born in that time. Then අපිට සාමාන්‍යයෙන් philosopher කෙනෙක්, scientist කෙනෙක්, ලේසියෙන් හොයාගන්න පුළුවන්. Can we find? No. In FB actually we have some philosophers. අර FB එකේ ඉන්නේ Right, okay, students, can you hear me? Please respond. Can you hear me? Right. Okay. Welcome to Sri Lanka. So this is what happened, right? Power cut. Power cut, actually nothing new to us, right? So anyhow, I had some fortune, right? So that's why suddenly power gone and power came, right? Okay. Anyhow, uh, everyone is okay, right? Good. Done. So what we were discussing actually, right? Yeah. Okay, right. We were discussing about philosophers, scientists, and many people. Actually, remember, students, in the ancient time, actually, the people actually they had time. They had time to think about this world, right? How the things are made, right? So, what are the things in the sky? Can we go to sky, right? So that's how the science, technology, all the subjects are born, right? So these philosophers are actually what? They are good thinkers. So we also like that only, right? But they thought in very broad way. They thought to find out new things, right? The first of all, remember, in Greek, we know that the country known as Greece, right? So Greek people. So in around Greece, around Rome only, actually most of the philosophers, most of the scientists, actually they were born, right? So they were thinking that, so some of the philosophers, they were thinking that how the material world is made. So that was a main question for them. How this material world is made. මේ අපේ වටේ තියෙන සියලුම දේවල් අපේ වටේ අපේ ළඟ තියෙන දේවල් මේව කොහොමද හැදිලා තියෙන්නේ, right? So the first name that coming to the place actually Empedocles. So he was a philosopher, right? He was a great philosopher. Remember the name in your resource book. They have clearly mentioned about him. Actually, there were many philosophers before him also, but we are not going to discuss about them here. But if you are really interested to find out the history of this one, you can search that one, and you can discuss this one with me also after the class, because actually in the class we cannot discuss these things further. We have no time to discuss. We don't have the time to waste this. So therefore, I'm giving you the things that related to us, right? So remember, students, as I mentioned you, these Greek philosophers, they were thinking in very different way. They had a broad thinking, and they were thinking about how this material world is made. So the first name that coming into the place, Empedocles, right? I will write down the name. I have given that one in the tutorial also. Empedocles. He was a great philosopher, right? So do you know that? What did he say? Anyone? What was the idea? What was the assumption that made by Empedocles? What do you think about that? Do you know? What did he say about this material world? We have to learn about these things. Anyone? Yes, very good. Remember, students, he was thinking that, he assumed that this material world is made by mainly four things, right? So the four things are like this. First one is earth. Second one is fire. Third one is water. And at last they were thinking that, he was thinking that air. So these are the four fundamental things that the material world is made. He was thinking like that. But remember, actually, at that time, this was a nice thinking. This was a great thinking, right? Philosopher, right? That's a philosophical idea, right? Earth, fire, water, and air. All right. So we know that by now, actually, they have made the films also. Can you remember recently the film came that Last Airbender? Did you watch that one? In Last Airbender also, actually, they are talking about the mainly they are talking about what? Air. But these are also what? Some of the, yeah, Avatar, right? Yeah, Avatar. So therefore, these are also fundamental particles, right? So it's not bad, right? But remember, this is not correctly explain how that matter is made, but we can get a rough idea, roughly idea. ඒ කියන්නේ අපිට නිකන් අර මතු පිටින් පේන දේ එයා දැකලා තියෙන මතු පිටින් පේන දේ. Right? So he has absorbed what he has seen here. So there were four fundamental particles: earth, that means soil, fire, water, and air. So this was the first thing that came into the play about the material world, about the matter. Can you understand? That's what happened. And then, if you have any doubts, put your doubts in the chat box. Huh? Don't speak to the mic. Right, okay. So, what is the next one actually? Who is the next one? Right. So, the next philosopher is actually Democritus. Right? Remember these names, huh? Actually, in the examination, they are not asking about these kind of simple things. But as a history, actually, we have to remember these things. Democritus. Democritus is actually also a famous philosopher that came into the play when we discuss about the history of the matter. History of the matter. So they were believing, that means Democritus, he put an idea about the atom in this way. He told that the atom is look like what exactly? The atom is actually invisible, indivisible, small particles, right? Look at this one. This idea is actually completely different from this one, right? Empedocles, actually, he said that everything in this material world is made by these four fundamental particles, as he said. But Democritus, a later philosopher, he said that the material world, that means the matter, is made by invisible, indivisible, small particles. Can you understand? So that was his idea, right? So that is correct, students. I'll tell you that one using a nice example, a simple example. Huh? Look at this one. Now, just imagine I have a small paper, right? Just imagine I have a small paper like this. Right? Can you see that this one? Yes. Now what I'm going to do is I'm going to tear this one in this way, right? Another particle. I'm going to tear this one into another one, another one, another piece, another piece. So likewise, until you can't tear this one, you can get a small particle like this. Now I have a small particle. You can't see that one, but I have a small particle. Can you see that? That means the Democritus idea was correct, right? Because he was telling that the material world, that means the matter, is made by invisible, indivisible, small particles. Correct. You can see that one. Small particles, we can see that, right? Now, if you consider a small ink, drop of ink, just imagine this ink drop. This ink drop is made by small ink particle that we cannot see, microscopic particles. So that was a simple idea. It was represented by the great philosopher Democritus. But remember, students, actually later they gave a name for this one as what? Atom. They told that this fundamental, invisible, indivisible, small particle is known as what? Atom. Do you know that atom term, that means the word atom, came from where exactly? That is a Greek term, Greek word. There was a Greek term in their language known as atomos, right? The correct term is atomos. So the atomos term means actually invisible, indivisible, indestructible particles, tiny particles. For them, actually they gave a name, that means they are, in their language, the name is atomos. So the later this term came into the atom. That's what we are going to learn here. Atomic theory. Can you understand? Right? Look at the history. History is starting with the Empedocles. Earth, fire, water, air are the fundamental particles according to Empedocles. And then Democritus, he said that the material world, the matter is made by invisible, indivisible, small, tiny particles which are indestructible. So those particles were named as what? Atom later. But the correct Greek term was atomos. But now we are using that one as what? Atom. Can you understand? Right. Now, look at this one. The next people, right? Now we learn about Empedocles, Democritus, and the next one, yes, very good. Who is that? Nuda, right? Okay, very good. So we are going to learn about Plato and Aristotle. Right? So write down their names correctly, yeah? Right. Okay. So remember, Plato and Aristotle actually they are playing huge role in history because of some philosophical, mathematical concept that they introduced to the world. So therefore, actually, they are a contribution to the development of the science subject. That means not only science, mathematical subject. We know that Aristotle is mainly famous for what? Mathematical subject, right? So therefore, their ideas were like this. They told that Aristotle and Plato, they gave an idea to the world like this, right? According to them, they told that no ultimate invisible particles in the matter, right? So this was their idea, Plato and Aristotle. So by the time actually the people, the ancient people actually, they were what? They were thinking that these ideas was correct. That means Plato and Aristotle, the idea they gave is correct. That means Empedocles, the ideas given by Empedocles, Democritus, those ideas was actually faded for many years. People actually forgot about those things. But Plato and Aristotle, they suddenly came and tell that no ultimate invisible particles in matter. Right? So the people accepted this one. The people accepted this idea. The reason is these both were very, 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 very famous philosophers, mathematicians, right? Very famous scientists. So therefore, they were giving idea like this. They give an idea like this. And then later, so for many years, the people were thinking that this idea was correct. Later, here comes the person. A person known as whom? John Dalton. Right? John Dalton. So this is the person actually. He is the person we want to learn. John Dalton was a scientist as well as a school teacher. So he told that the ideas came from the Empedocles and Democritus. He gathered them and he developed an atomic theory. He introduced a perfect theory for the atom. Now, these were actually philosophical ideas. They just tell. Empedocles, actually, he said that, yeah, matter is made by these four fundamental particles. That's all. Democritus, he said that matter is made by invisible, indivisible, small, indestructible particles. So, like that. That was an idea. No perfection, no proof for that one. So, Plato and Aristotle were also telling that, they also told that their idea was completely different. No ultimate indivisible particles in matter. So they told like that. So therefore, John Dalton experimentally, he proved that yes, matter is made by a fundamental particle. A fundamental particle known as what? Matter is made by a fundamental particle particle known as atom. I told you how that term atom came. The Greek term was atomos, but later this converted into atom. So this is how actually they introduced the idea about the atomic theory. Okay. So in your resource book, remember students, they have mentioned these 5 names specifically. They have given what was the idea from Empedocles. They were telling that they told that what is the idea from Democritus and what was the different idea of Plato and Aristotle. And then later they have clearly told that John Dalton, the famous scientist and school teacher, he was introduced this one as a theory that fundamental particle in matter is what? Atom. So this is the atomic theory. Now, what are the doubts you have? Yes. Let's see what are the doubts you have. If you have any doubts, tell me, right? So can we have the, yes, recordings you can have, right? Don't worry. So all must buy the resource book, right? Yes, you must buy the resource book. Plato and Aristotle, I didn't understand their theory. So is John Dalton model is the golf model? Yes. So are all of them Greek people? Yes. John Dalton proved that one. I didn't understand theory that. So what about Lavoisier and Joseph Proust? Yeah, right. Okay. Now, most of you are asking, sir, what does mean by the idea? What is the idea that came by Plato and Aristotle? Most of you are asking. So, students, simple, right? They have given that no ultimate indivisible particle. If I write here indivisible particle. Now, what was the idea by Democritus? Democritus said that the atom can be divided into ultimately a small particle, tiny particle. So therefore, he has given that indivisible, small particles. But Plato and Aristotle, they are telling completely opposite of this one. That means if you take a matter, right, a matter particle, they are telling that this cannot be destroyed into ultimate particles, right? So they are telling that no ultimate indivisible particles. There are no indivisible particles, right? Ultimately, no indivisible particles. So that is actually completely opposite of the Democritus idea. They think that atom is as it is. We cannot destroy that one. Can you understand? Raise your hand who understood that one. Please raise your hand. Okay. Yeah, that cannot be accepted. Yes, that is wrong. We can understand that one, right? So that means it can be divided further and further and further. Yes, it can be divided further and again further. But Plato and Aristotle, they are telling that it cannot happen. There are no ultimate indivisible particles. It's not correct, right? We can see that if you, just now I told you that if you take a piece of paper, we can ultimately divide that one into small particles. But Plato and Aristotle, they are telling that it cannot happen, right? We don't know by depending on what they have told this one. Yes, you can search their history and find out what are their philosophical ideas. Okay, philosophers means actually what? So different thinkers, they may have different ideas. But remember, anyhow, there was another question in the chat box. I saw that one. Remember, students, Empedocles, Democritus, Plato, Aristotle, these people actually came from Greek. So, Ekulange country Greece here. But John Dalton is actually English scientist, right? In history, actually, he has introduced as English scientist. Again, British skill, right? English scientist, not Greek, right? John Dalton. We know that John name is actually definitely, that's the English name, right? So therefore, John Dalton, right? So therefore, later, John Dalton introduced this one as a theory that a fundamental particle of the matter is known as, right? So I have given you these things. If you have any doubts, put your doubts in the chat box quickly before I move for the next topic. If you have any doubts, please read the tutorial. Everything that I explain here, I have given you in the tutorial. Please go through these things, right? And one more thing I want to tell you, right? You don't have to waste time on these things, huh? But if you are interested, you find the history and improve your knowledge. Doesn't matter. But these things are not that much important. But among these 5 names, actually, the important as well. Okay, right. Right. Okay. So will they ask about these philosophers? No, no. They won't ask, right? So whose theory is acceptable among all 5 people? Yes, that's it. That is a good question. Among these 4 theories, actually, we have only 4 theories here. John Dalton's theory is only accepted one. But remember, now John Dalton's theory is also wrong. Why? The fundamental particle of matter is that atom. Fundamental particle. So now the next topic is actually subatomic particles. So therefore, we have electron, proton, neutrons also. So how we can say that the fundamental particle is atom when there are subatomic particles? So therefore, but anyhow, among these 4 theories, the most acceptable theory is what? John Dalton's fundamental particle atom theory, atomic theory, right? Our topic is atomic theory. Atomic theory was introduced by John Dalton. Among these 4, the most acceptable ones. Okay, good. Very good questions. Yes, yeah, Teshala, very good. So protons and neutrons are made from quarks, so all concepts are wrong. Yes. Further, we have some particles, electrons, protons also made by some other particles. So we don't go that much far in our A-level syllabus, right? I told you that the Mehemai, the first thing you have to understand is, in all time, you have been cheated. Why? Because you didn't learn about the proper chemistry or proper physics or proper biology in science only. You have just touched the surface, right? Now only you are going to jump to the sea to see the depth. But you see the depth, you can't swim there. Understood? So if you want to swim there, you need a lot of knowledge. You need a lot of what? Technology. You need a lot of necessary things, right? Just now you started, you will learn many more things in your further higher studies, right? My request is, students, remember, go for the university, right? It's not only about a government university. Try to go for a university, definitely. In order to do any subject, go for a university, then only you will understand the depth of the subjects we are learning. Chemistry is not limited. I'm not the one who know everything about the chemistry, right? I know everything about your syllabus and some other things that I learned from my university. I know about some part of the chemistry. That's all, right? I'm not the god of chemistry, right? So there are so many things to learn. If you consider our university lecturers, those who did a PhD, right? Many PhDs, master degrees, right? So they have a lot of qualifications. They are still studying. Understood? So therefore, these subjects are completely open for you all, but you have to search. Understood? First of all, you have to go for the university. In A level, you study these things. You have to learn. So in A level also, actually, we are touching only few areas, not all of them. Now, we are learning that subatomic particles are electrons, protons, neutrons, but there are other subatomic particles also. But I don't want to discuss those things here. I don't want to confuse you here, right? I agree they are indivisible. Answer, I found that we do have quarks inside. Yes. Indivisible means cannot be divided. Yes. Yeah. That is the idea. Right. Okay. So these ideas are given in the tutorial. Please read this one. So day by day, those concepts change and science gets new. Yes, that's what happened. We don't know in 100 years what will happen. Remember, students, now in the periodic table, 118 elements are there. 2 elements are under construction. They are finding actually new. They have already found those 2 new elements. You can Google that one. You can find that one. But they are finding the chemical properties and everything, and they include that one into the periodic table within a decade or 2 decades. We don't know. But in another 100 years, subject science, that means all the branches, chemistry, physics, biology, everything is related to each other. So therefore, everything will be changed in another 100 years. We don't know. So why isn't John Dalton theory is incorrect? Because atoms is the smallest unit and it's made of subatomic particles. So his theory should be correct, isn't it? It's like this, right? Now, just imagine he told that the fundamental particle is atom. He found that one. But remember, after finding the subatomic fundamental particles means what? Fundamental particles should be fundamental. That means further we cannot divide that. But if you consider atom, we can divide that one into subatomic particles. Then those subatomic particles are the fundamental units. Then how that can be? Can you understand? So therefore, John Dalton's theory, that is also has a lack. It's not completed. He just came up to atom only, but he didn't discover electrons are there, protons are there, neutrons are there. Understood? In your O-level time, you learned that yes, the fundamental particle of matter is atom, but in A-level, further, you're not going to learn that one anymore because we have another subatomic particles also. Then those are the fundamental particles. So then can we name one particle as fundamental particle? No, we can't. Because if you analyze the subatomic particles are also 3 types: electron, proton, neutrons. And again, you are learning electron, protons are made by these things, quarks and everything. So therefore, everything is actually what? Now becoming divisible. Okay? Now John Dalton, so democratizing, so these kind of scientists, they were thinking that atom, we cannot divide that one further. Later, another 100 years, they found that yes, we can divide that one. Another 100 years, we are finding that electrons, protons can be divided, quarks. Later, we will find that quarks will be divided. So that's how the science is updated. This is just the history, students. Understood? History can be correct, can be wrong. You have learned history in Sri Lankan history. History can be wrong, right? We don't know, right? But history teaches us so many lessons. So who discovered subatomic particles? Yes, we are going to learn that one. Electron was found by J.J. Thomson. Electrons were found by J.J. Thomson. Proton was found by Eugene Goldstein. And the neutron was found by James Chadwick. We are going to learn that one under the subatomic particles. Right. Now, let's see what are the further things included by this scientist John Dalton. right? Let's see what John Dalton exactly said about this atomic theory. So can't we further divide them? Electrons, protons and neutrons can be divided into radiations. They are emitting radiations also, and quarks like particles also there. And up to that one, actually, further scientists haven't find anything related to that one. But you also can try, right? You also can give it a try. Become a scientist and give it a try. Right. Now, the thing is, so this is a question that I given you in the tutorial. 4 postulates of Dalton's atomic theory. Right. Let's see actually what John Dalton said about the atom further. Let's see what are the postulates. Right. Write with me one by one quickly. With me. I'm going to explain them. But before that, quickly write down one by one. Elements are made out of extremely small indivisible particles called atoms, right? So as I mentioned, elements are made out of extremely small indivisible particles called atoms. So he told that the fundamental particle is atom. The tiniest particle, the tiny particle is, so this is the first postulate. And the second one, quickly with me. All atoms of a given element, all atoms of a given element are identical in mass and size. Mass and size, right? All atoms of a given element are identical in mass and size. But the atoms of one element, are different from the atoms of all other elements. So how we can explain this statement? Look at this one. This is very important. All atoms of a given element are identical. That means if you consider a particular element, let me take here nitrogen, right? Let me take nitrogen element. Atoms of a given element are identical in mass and size. Now, if you consider nitrogen gas sample, there are so many nitrogen atoms. First of all, nitrogen molecules are there. Inside the molecules, there are 2 nitrogen atoms. So therefore, there are so many nitrogen atoms. So John Dalton said that these atoms are equal in size as well as mass. That is the first assumption that we discuss about the elements, right? In the first postulate, he talked about the elements are made out of extremely small indivisible particles called atoms. So these atoms are different types. Later they found the periodic table: hydrogen, helium, lithium, beryllium, boron. Likewise, up to the first 20 elements they found. Then they found that different type of atoms are there. They gave the name as elements. So when you consider nitrogen as a gas, In nitrogen element, there are nitrogen atoms. All of them are same in the size as well as the mass. Got it? But when you consider oxygen, right? Just consider oxygen atom, one oxygen atom and one nitrogen atom. Are they equal? According to the postulate of Dalton, are they equal? Nitrogen and oxygen? No. They are not equal. Nah? They are not equal. Nitrogen atom is completely different in size as well as in mass. Oxygen atom is completely different. Right? So you have to keep that in your mind. Understood? Nitrogen atom, oxygen atom, if you consider different two different elements, their atoms are not equal in size or mass. So that's what they have given. He has given. But the atoms of one element are different from the atoms of all other elements. If you consider nitrogen atom is completely different from the other elements atoms. Oxygen, helium, hydrogen, carbon, chlorine, neon. So that is the second postulate. Okay, quickly write out. Quickly. Yes, we have doubts. So, but I guess that statement is wrong because ions and isotopes of same element different. Yes. Remember, now they have given that here nitrogen atom and oxygen atom. Have you learned isotopes in your O-level time? Isotopes? Yes. If you have learned isotopes, remember in isotopes the number of neutrons are changing. So these are later things. So isotopes were found in later time. So therefore, these are the postulates of John Dalton theory after he found that the fundamental particle of atom. Some of the postulates can be wrong. So as you mentioned, this postulate is wrong. The nice example is isotope, because when you consider isotope, the number of neutrons are completely different. When the neutrons are different, what will happen to the masses? Now, just imagine, students, we know that, I don't know whether you have learned about this thing. Hydrogen has three isotopes, hydrogen 1,1, hydrogen 1,2, and hydrogen 1,3. Right? So this is considered as protium, deuterium, tritium. Can you remember? I think you have learned this one, right? So when you analyze these three isotopes, their sizes are different. Then this statement is completely wrong. Because same element, three different atoms. Neither. So therefore, this statement is wrong. Right. So we are not going to check whether these statements are correct or wrong, but here we are just learning postulates of Dalton's atomic theory, right? But that is a good point that you understood this statement is wrong. Very good. I really appreciate that one. Later we will learn isotopes. At that time we can discuss about this further. Right. Shall we move for the next one? Anything else? Yes. Who's that? Teshalane. Very good. Huh? So can we write these in our own words in exam, or should we write the exact words? Right. So this is the thing. හොඳට මතක තියාගන්න මේ මුකුත් අහන්නේ නැහැ. So එහෙනම් ඇයි උගන්වන්නේ මේවා? නේද? මේව උගන්වන්න එපා පොඩ්ඩක් අපි background එක පොඩ්ඩක් ලස්සනට touch කරගෙන එනවා. Understood? Now when you are learning in O level, actually you are starting from simple calculations, right? Body calculations වලින් පටන් ගන්න. හැබැයි ඒවා exam එකට අහනවද? No, right? So these things are also like this. They are not asking these things in exam. But since you asked, remember, if they have asked this one, you should be able to write these things by your own. ඒ කියන්නේ මේවා කටපාඩම් කරන්න එපා. My first advice is this one. So now can't you tell this first idea in your terms? What is the first idea? The first idea is the particles, that means the matter is made by indivisible, invisible, indestructible small particles. So ඒකන මේක කියලා තියෙනවා. So you can write down your own line. What is the second one? Second idea, if you get the idea, ඒකයි මම කිව්වේ. අහගෙන ඉඳලා idea එක ඔලුවට දාගන්න. එතකොට ඔයාට automatically ඔයාට එනවා chemistry නිකන් අර naturally එනවා. effort එකක් දාන්න නැතුව naturally අපි කියනවා spontaneously කියලා. Spontaneous reactions, do you know spontaneous reactions? ඉබේ සිදුවන ප්‍රතික්‍රියා. Understood? So likewise, now second statement is what? The atoms are made by the atoms of a given element. Atoms of a given element is same in the size as well as mass. But if you consider two different elements, their masses and sizes are completely different from each other. ඒක ඔයාගේ idea එකෙන් ලියන්න. Yes, that's the way. Very good. Anything else you want to ask? So which is the largest atom among all? I'll tell like this. Largest atom we don't know yet because we don't know the elements that we need to find. So therefore we cannot guess the largest atom. But I'll tell you like this. The smallest atom, who is it? Anyone? Smallest atom. Anyone here? Let's see, any one of you will give the correct. Right. Now all of you said hydrogen. Okay. Any different answer? Any different answer from anyone? Who is that? Amina Yasin. Yes. Senutni, yes. Your two answers are correct. Yes, very good. Remember, students, the smallest atom is not hydrogen. It is helium. Sir, helium is the second element, right? So how it can be the smallest element? Later. Radius, atomic radius, periodic trends. Under the periodic trends, we are going to learn that atomic radius. Okay, so you can search that one now. Right. So third one. Let's move for the third point quickly. So today we have to finish this one. So look at this one. The third idea, atoms are neither created nor destroyed in chemical reactions. In chemical reactions. Right. What do you think about this statement? Is this correct or wrong? Atoms are neither created nor destroyed in chemical reactions. False, completely false. So now remember, this is actually, these are basic. You can go to paran idea. Now just imagine sodium. Sodium atom is forming sodium plus iron in a chemical reaction. So therefore the statement atoms are neither created nor destroyed is wrong. See, we have destroyed that by removing one electron. Do you know that we can remove electrons from atom? Ionization. We have separate topic known as ionization. Nuclear reactions, of course. But remember, and this is a chemical reaction. No? We are discussing about chemical reactions, not the nuclear reactions. Nuclear reactions are different. Chemical reactions are different. Yes, good, very good. But anyway, we can destroy the atom. So this is the third postulate. What about the fourth one? The fourth one is compounds are formed by union of two or more atoms of different elements in a simple numerical ratio. Simple numerical ratio. Complete the note quickly. Compounds are formed by union of two or more atoms of different elements in a simple numerical ratio. So students, for example, when you consider water molecule, Water is a compound, right? So compounds are formed by union of two or more elements. Yeah, it can be the minimum is 2, but more than that also can be there, right? If you consider glucose, C6H12O6. So here we have 3 different elements. So union of 2 different elements in simple ratio, 2:1. Just consider ammonia, nitrogen, hydrogen, completely 2 different elements, 1:3 ratio. So here glucose, we have 3 elements, 6, 12, 6. We can take that the simplest ratio is 1:2:1. Later we learned that this one is a what? Empirical formula. And this is molecular formula, right? In chemical calculations, we are learning that. But anyhow, compounds are made by the simple numerical ratio between the atoms. So they are union, right? So that's what the idea they have given. So, but they are great, right? Because they found them without the help of the technology. Yes, of course. Remember, they found these things without the technology. Yeah? So that is the main thing. Now, even we have the technology, we can't go further. It's very difficult. So therefore, think about their thinking. That's why I told you. So can we convert new element by emitting radiations, right? Yes, of course. We are going to learn about nuclear reactions. Am I wrong about what? Am I wrong? Yeah. We can form new elements by emitting radiations. Yes. Very good. So, but C3H8 is a not numerical ratio, so it's a false statement. C3H8 is not a numerical ratio. A numerical ratio in the sense they have given that these values, numerical numbers, that means 2:1, right? So that kind of a ratio. Now, if you consider hydrocarbon C3H, C3H8, 3 carbon atoms and 8 hydrogen atoms. So that's what they have given in numerical ratio. Aren't there compounds made of complex ratios? Are there compounds made of complex ratios? Complex ratios are there. Actually, but we are not going to discuss about those things. Complex ratios are very complicated, right? First of all, you learn about these things, right? So one of you told me that you didn't get the 4th point. I'll explain that one. Compounds are formed by union of 2 or more atoms. Look at this one. Water molecule is a compound made by 2 hydrogen atoms and 1 oxygen atom. Union of 3 different atoms, right? That means same element, 2 atoms, and different element, another atom. So therefore, union of few elements, few atoms are forming compounds. That's all. So these are the postulates given by Dalton's atomic theory. And I want to remind you that here, we are going to discuss this one later again. Remember, students, we have to discuss about the atomic models. When we are discussing about the atomic models, we have 5 types. What is the first type? I told you that one. What was the first type I told you? Anyone? What was the first type I told you? Atomic model. Dalton's golf ball model. Do you know golf ball? What look like golf ball? Golf ball is very hard. Understood? Golf ball is very hard. We can't destruct that. You can't break that one into particles. So that John Dalton assumed that atom is look like a golf ball. But is that correct? Can't we destroy atom? Can't we have subatomic particles inside atom? Later, J.J. Thomson, James Chadwick, Eugene Goldstein, like scientists, they proved that atom can destroy into subatomic particles. Electrons, protons, neutrons. Understood? So the first atomic model is very unsuccessful. So that means when you consider these postulates, we can consider that these are not correct at the all time. These are not all time correct statements, right? We told, right? We told the few elements of few statements are wrong. What about the third one? We discussed about the second one also. First one is anyway wrong because inside that we have things, right? Fourth one is, yeah, okay. Numerical ratio means in the sense that simple elements now. So therefore, this is okay, compounds. But there are some compounds actually made by complex numerical ratio also. So we are not going to discuss about those things here. So therefore, these are just postulates made by John Dalton, right? So these are not all time correct. Can you understand? Yes, if you have any doubts, put your doubts. So that means Dalton's discovery pioneered in discovering fundamental of matter in the present, sir. Yes, right? Actually, this is started by those ancient philosophers, right? MP doctors, like those philosophers. So they were the actually people who raised the curiosity of finding these things. But John Dalton kept very important step on finding the subatomic particles. So do atoms too bound with elements? So atoms too bound with elements. What is that? Remember, element means the type of the atom. That means if I consider, now here we have two hydrogen atoms. No? So what is the type of element? Hydrogen. Here we have one oxygen atom. What is the type of element? Oxygen. Understood? Right. Okay. Now, so this is the four postulates. Did you write down these things quickly? Shall we move for the next topic? Yes. Let's move for the next topic, discovery of electron. Our next topic is discovery of electron. Right. Students, I told you at the beginning of the class, we have to learn three stories, three main stories. So today we are going to discuss about the story of the electron. And in the next class, we are going to discuss about the story of proton and neutron. So let's begin how they discovered the very first subatomic particle inside the atom. What is it? Electron, right? Look at this one. This is very, very, very important. Right, okay. But before that, please raise your hand who understood everything, that we discussed quickly. Please raise your hand who understood everything that we discussed here. Good. And others, if you don't understood anything, put your doubts in the chat box. If you didn't understand anything, put your doubts in the chat box. I will clear them. Because I want you to understand everything that we are going to discuss in our class, right? I want you to understand these things properly from the beginning, right? So, ladies and gentlemen, our next topic is discovery of electron. Now, the discovery of electron is actually very interesting. Do you know that this was an accident, right? This was an accident. Keep that in your mind. There are three subatomic particles, mainly in atom. Three subatomic particles inside the atom: electron, proton, neutron. These are the main subatomic particles: electron, proton, and neutron. And now we are going to discuss about the electron. Remember, students, there was a scientist known as actually, do you know him? Check the name. Look at the name. Do you know him? Who is he? Michael Faraday. What do you know about Michael Faraday? How the mayor? Mayor of father of what? Father of what? Electricity. Yes. Right. Vidyute piya kila tama api meyaට කියන්නේ. Michael Faraday. So what is the contribution? So why in the discovery of electron, why we are discussing about Michael Faraday? We must discuss about him. Right? Look at this only. Why we need to discuss about him? The reason is Michael Faraday contributed by doing experiments on electricity. We know that, students, our topic is matter, and apart from it, we have another thing in universe, energy. So the electricity is also some kind of energy, electrical energy, right? And I told you that matter and energy has a strong relationship. Michael Faraday at that time period, so he was conducting, right? So he actually conducted so many experiments on electricity. So one of the famous experiment is actually he tried to conduct the current electricity through the solid medium in solid matter, and he tried to conduct the current electricity through the liquid medium. He passed both the tests. He did that one. We are going to discuss the main thing, actually, the passing current electricity in a liquid medium. We are going to discuss in electrochemistry. Unit number 13, can you remember? I taught you the syllabus. In unit number 13, we have two laws, Faraday first law, Faraday second law. Electrical charge is measured by Coulomb. Electrical charges can be passed through the solid medium, can pass through the liquid medium. Those things found by this person, Michael Faraday. So therefore, he has gained huge respect of finding something related to the electrical energy. Understood? Electrical energy. So Michael Faraday at that time, he was conducting experiments on what? Electricity, passing current electricity through solid medium or liquid medium. But remember, later they found that there is a small particle that can carry electricity, right? So the small particle that can carry the electricity, they were considered as electron. So that means electron was found by Michael Faraday. No, students. Wait. Right? Michael Faraday found that there is a particle that can carry electricity. Later, there is a scientist known as Johnston G. Stoney. What is the name? Johnston G. Stoney. So this scientist named this particle as electron. Since it is carrying electricity, it is known as electron. Understood? Electron is the fundamental particle in what? Electricity. Can you understand? Now, Michael Faraday tried to pass the current electricity through solid medium and liquid medium. Right? He passed both of the tests. Yes. Solid pass the current electricity, especially metals. Liquids also passing the current electricity, especially aqueous solutions. Then some bunch of scientists, ඉස්සර කාලේ හිටපු සයන්ටිස්ට්ලා නිකන් හිටියේ නෑ. ඒගොල්ලන්ට වැඩ වැඩි. හැමදේම ටෙස්ට් කරනවා. හැමදේම හොයනවා. So they found everything. So Michael Faraday from other side is doing some experiments on electricity. Some bunch of the scientists, they actually conducted few experiments like this. I'll first of all put the names up. The first name is actually Sir William Crookes. Students, you have to remember these names. මේ නම් මතක තියාගන්න වෙන ඕගලන්ට, right? Anyhow, Sir William Crookes. And here is the next one. You know about him. Who is he? JJT. Pet name is JJT. JJ Thomson. And next one is Wilhelm Hittorf. Right? Another one, Julius Plucker. So these bunch of scientists actually conducted some experiments whether current electricity can pass through the gas medium. Right? So these scientists conducted an experiment to check whether current electricity can pass through gas medium. Right. Now look at this one very carefully. Look at this one. Sir William Crookes, J.J. Thomson, Wilhelm Hittorf, Julius Plucker. These bunch of scientists conducted an experiment to check whether current electricity passed through the gas. What do you think? Is that possible? Michael Faraday found that solid and liquids can pass the current electricity. Later, Johnston G. Stoney named that one as electron, the fundamental part. Then gas කියලා ගැන වාතය. දැන් ඔයාට මේ ඇට්මොස්ෆියර් එකේ මෙහෙම ඉදිද්දි පට ගාලා කරන්ට් එක වදිනවද? ඔයා ඔහොම ඉදිද්දි මෙහෙම පට ගාලා වදිනවද? Because in atmosphere actually gases are there. 78% is nitrogen, and we are inhaling oxygen, carbon dioxide, argon, likewise gases are there. Then මෙහෙම ඉන්නකොට ඔයාලා කරන්ට් එක වදිනවද? No, right? So therefore it's very difficult. So but lightning, yeah, lightning is different thing. Lightning is different thing, but I'm asking in here, when we are just staying here at home, the makeup of the atmosphere again. Lightning is a different scenario. I'm asking under normal conditions, right? Do you feel that the gases, atmosphere gases are passing current electricity? No, right? So you don't feel that one. So therefore it's a different case. Different case in the sense, it required some different situations, some different conditions to pass the current electricity through the gas medium. Understood? So they conducted an experiment for this one. That experiment was known as what? Tell me. Put your answer in the chat box. What is the experiment they conducted to pass the current electricity through the gas medium? Remember the name. The experiment is cathode ray experiment. This is the first thing that you will be questioned at the exam. ඔන්න ඔයගලන්ට questions අහන පළවෙනි තැන. What about the cathode ray experiment? After today's class, you should be able to explain the cathode ray experiment to yourself. Right? So shall I give you a chance to explain the cathode ray experiment after the class? Anyone? I will let you to speak to Mike. Anyone here? Right, okay, let's see that one at the end of the class. Right, students. So remember, in order to pass the current electricity through a gas medium, they conducted an experiment. That experiment is known as cathode ray experiment. What is that experiment? Cathode ray experiment. Understood? Cathode ray experiment. So in order to do the cathode ray experiment, they built a specific instrument, a specific setup. So that setup is known as cathode ray tube. What is it? Cathode ray tube, or else this is known as Crookes tube. Crookes tube. So why they have given Crookes tube? May, can you see the name? Sir William Crookes. Before the J.J. Thomson's name, I wrote here Sir William Crookes. Actually, he is the person who found this setup. But later, Thomson, Wilhelm, Julius, like scientists, they use this setup in order to continue that experiment. Right? So, students, now we are learning that Sir William Crookes, J.J. Thomson, Wilhelm Fitov, Julius Plucker, like scientists, conducted an experiment to check whether current electricity passed through the gaseous. So the experiment they conducted was cathode ray experiment, right? So the setup that they have created is what? Cathode ray or Crookes tube, right? Right. So that means still they didn't find electrons, right? Yes. So then what about this one? I told you, right? I told you that this is the particle, subatomic particle in energy. Our intention is to find out what are the subatomic particles, what are the fundamental particles in matter. For now, we know that matter is made by atom. That's all. But in electricity, as an energy, electricity carried by small particles known as electron. That's all. That's a different part. Energy, and we are going in the matter part. Right? I told you that finding electron is some kind of an accident. Look at that accident, how that happened. So the honor goes for these scientists. Let's see what is the setup, right? First of all, can you briefly write down these things in your notebook if you don't have the note in a tutorial? Quickly. I have given these things in the tutorial. Others, those who have the tutorials, you don't have to write down. Please, others, quickly note down this one. Quickly. Please, if you have any doubts, put your doubts in the chat box. Huh? Right. Okay, are we done? Quickly finish writing this one. Right. Make a short note, right? So write this one as a short note until you get the tutorial. Just write down this one, okay? That's enough. Right, okay, done. Good. Right. Now, let's see what is the experiment conducted by these scientists. Right. So I told you that this experiment was known as cathode ray experiment. What is it? Cathode ray experiment. Let's see what is cathode ray experiment exactly. What is it? Let's see what is exactly the cathode ray experiment. Look at this one. Right. Now, look at this one very carefully. I'm going to draw a setup here and I'll explain the setup and what was happening there exactly. Right. Those who have the tutorial, turn to the page number 5. After the cathode ray tube, you can draw this setup with me. Others, take out your notebook. So you have the notebook with you. You draw this one with me. I have given this setup in the tutorial, but again, I have given you space to draw this one because this is very important. Sometimes in your term test examination, they might ask you to draw this one. So therefore, you should be able to draw this one. Right. So ladies and gentlemen, this is the cathode ray tube. Some people consider this one as discharge tube. There are so many names: Crookes tube, cathode ray tube, discharge tube. Nam good idea. And these are two metals known as, this is negatively charged and this is positively charged. This is considered as cathode. Right? And this positively charged metal is known as anode. Got it? And remember, students, these two metal plates are connected to a high voltage source. Do you know that high voltage source, the minimum value, the minimum high voltage here is actually 10 kilovolts, right? So 10 kilovolts, right? High voltage, this is the minimum value. Minimum value, definitely it should be more than 10 kilovolts. So this is the high voltage source. Now these two metals are connected to this high voltage source. Please draw this diagram with me. Doesn't matter whether this is what, beautiful or ugly or, doesn't matter, you just draw this one. Okay, right? And here we have a pressure pump, a vacuum that we can maintain the pressure in the tube, right? So remember, students, they have injected helium gas into this setup because helium, hydrogen like gases are very lightest gases. Why they have injected helium and not hydrogen? Hydrogen can react. Hydrogen can easily react, but helium is inert gas. Helium is not reacting. Can you remember? That's a noble gas. You have learned that one. Helium is not forming chemical bonds, right? So therefore, they have used here the lightest unreactive, that is noble gas, helium. So this is the setup. Now what happened? So here they have used they have reduced the pressure inside this glass tube up to 1/100 mercury millimeter, right? Sometimes they say that okay, wait a minute. Give me. Now okay. Now you can see me, right? Okay, right. So in some reference books, they have given that the pressure is about 0.001 mercury millimeter. That means 1/10,000, right? So 1/1000 or 1/10,000. So mercury millimeter. Sometimes in some reference books they have given, but definitely that should be lesser than 0.01 mercury millimeter. You know that 1/100 means 0. Less than that. That means very, very low pressure. Okay. So this is the experimental setup, right? So what was their purpose? Their intention was to find out whether the current electricity passed through the gas medium, because they have used helium gas. So they check. So suddenly they so like this, right? Actually they have coated in the anode side. So this is a glass bowl, right? In this glass bowl anode side, they have coated, students, zinc sulfide. This is zinc sulfide coated fluorescent screen, right? A zinc sulfide. So this is actually zinc sulfide. Nah? Zn means zinc sulfide. Zinc sulfide is a white color. ඒක නිකන් අර white board එකේ තියෙනා වගේ ඒක සාමාන්‍ය radiations වලට sensitive, right? So zinc sulfide compound is sensitive for the radiation. So therefore, in order to see the radiations, we are using zinc sulfide coated fluorescent screens, right? So they have used here a fluorescent screen at the opposite, that means the anode side of the cathode ray tube. So they suddenly saw that a green color glow appeared on this sensitive screen, right? On sensitive screen, they saw that a green glow appeared on it, right? That means some of the radiations are emitting from the cathode side, students. From the cathode side, radiations are emitting. That's why the green color glow appeared on the sensitive screen. Understood? They observed that a green color glow appeared on the anode side sensitive screen, zinc sulfide coated sensitive screen, and they proved that, they found that these radiations are emitted from the cathode side, from the cathode. Understood? So these cathodes, yeah, I'll explain it again. These radiations were known as what? Cathode rays. Right. I'll explain it again. Look at this one. Some of you are asking me to explain it again. Doesn't matter. So students, what happened was, we had a setup. They created a setup. So in this setup, we have two metal plates, cathode and the anode. And these two metal plates were connected to the high voltage source, which has a greater than 10 kilovolts. And they maintain the pressure at 0.01, lesser than that. I'll tell you why this kind of high voltage source and why this kind of low pressure. I'll tell you what are the reasons behind it, right? And they have injected helium gas inside this setup, right? They have injected. So here we have a pressure controller or vacuum controller. Here zinc sulfide coated. So now they have increased this voltage source. Just imagine this is increased to 1 kilo, 2, 3, 4, 5, 10, 15. Likewise, when they increase this high voltage source, when you adjust the voltage, what happened? They saw that a green color glow appeared on the anode side. See, this is positively charged anode metal. On the anode side, on the sensitive screen, zinc sulfide sensitive screen, they observed that a green color glow appeared on it. ඒ කියන්නේ මේ area එක කොළ පාට වෙනවා දැක්කා. They saw that this area is green color. එතකොට මේක නිකන් green color වෙන්න බෑනේ. ඒක පාට දැන් සුදු පාට screen එකක් තියෙනවා. ඒක එකපාරට කොළ පාට එනවා. කියන මොකක් හරි එකක් ඒක ඇවිල්ලා වදිනවනේ නේ. So you can understand that some of the things are, that means something is what colliding with that sensitive screen. So later they found that what are they? Radiations which are emitted by the cathode. So how they discovered that exactly cathode is emitting that one? මේකට පිටිපස්සේ මේ කියන්නේ මේ cathode ray මේ tube එකට පිටිපස්සේ මෙහෙම පිටිපස්සෙන් sensitive screen එකක් තියලා බලුවොත් කොළ පාට radiations මෙහෙම යනවා පේනවා. Right? So is that mean cathode rays are green color? No, Baba. No. Cathode rays are not green color. Because of the zinc sulfide coated sensitive screen only, we can see that cathode rays are in green color. මේක මම 25 batch එකටත් කියලා දුන්නා හරියට. මොකද මට පොඩ්ඩක් එක්ස්පීරියන්ස් දෙනවා මම ඔය පන්ති පටන් ගන්න කාලේ සමහර ළමයින්ට මේක කියලා දෙද්දි they asking sir whether cathode rays are green color. So that's why we can see this green color glow. That means cathode rays are green color. No students, it's not like that. We can see this green color because of zinc sulfide coated fluorescent screen. Ek radiations walata sensitive screen ekak. That's why we can see that one in green color. Understood? If not, cathode rays are not green color, okay? Are cathode rays green color? Tell me, yes or no? Quickly in the chat box. Are cathode rays green color? Ah, good, very good. No, yes. No, 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 huh? No. So what happened was actually when they increase this high voltage source, when they increase this voltage, they observe that a green color glow appeared on the sensitive screen. They decided anyhow, they found that this green color glow is emitting from the cathode. They named this one as what? Cathode rays. Cathode rays, right? So this is cathode ray experiment. Now what are the doubts you have? Before I explain that one, the things I want to explain a few things here, but let's see what are the questions we have. So why in diagram positive is connected to positive? Positive is connected to positive? Yeah, I can understand. What is 1 over 100 mercury millimeter? 1 over 100 mercury millimeter means pressure. This is actually way of measuring the pressure. Can you remember in your level time, I don't know whether in physics you have learned that one. 760 mercury millimeter is equal to 1 atm pressure. 1 atm is atmospheric pressure, right? 760 mercury millimeter. Okay, that means if you have a mercury, a tall mercury liquid which is 760 millimeters in length, in height, we can consider that that is equal to the pressure created by it is equal to atmospheric pressure. So here they have reduced the pressure up to 1 over 100. So I will write down this one here 0.01, and you can understand how small the pressure is. How small the pressure is inside the glass tube. Understood? Yeah, blood pressure is 120/80. Likewise, mercury millimeter is actually unit to measure the pressure. So what is the reason for the zinc sulfide, and why is it at the anode? Right. Zinc sulfide is to identify this green color glow. Zinc sulfide is to identify whether the radiations are emitted by the cathode. They have kept this same thing in the other side also, but later I'll discuss that one later. That one from the other side also actually they had some radiations, but mainly they observed that a green color glow in this side, right? And the other side later, right? The next subatomic particle. Wait, I don't want to make that curiosity here, but try to understand. They wanted to identify here whether the radiations are emitting, so they kept zinc sulfide coated sensitive screen and they observed the green color glow, right? So maybe because more electrons travel through the wire and high voltage increase. Yeah, I'll tell you what is the reason behind. Yes, they are invisible without the coating. Yes, they are invisible without the coating. Right, okay. Now, most of you have a question like this. So why do we have this much of low pressure and high voltage? Remember students, the reason of supplying this much of high voltages, they wanted to see that whether the current electricity passed through this cathode to anode. So therefore, the reason why they use here high voltage, because of the high voltage, we can see that from the metal, the electrons, that means actually from the metal, the particles are removing from the metal. That means electrons are removing from the metal and going in high speed. So that is the purpose of using high voltage source. Using high voltage source, we can see that whether there is some kind of appearances, whether there are particles moving from the cathode to anode. It will be convenient by adding high
Suppose
voltage.
Senate.
Can you understand? If you have any doubts, don't speak to Mike. Put your doubts in the chat box. Anything? Right. Look at this one. I was explaining here why we are applying high voltage source. The reason is by applying here small voltage value, we cannot see anything in the cathode ray. So they need some kind of observation, right? We know that when we are conducting an experiment, observation, then only conclusion. So in order to get a proper observation, they used here high voltage source. Then only if the particles are removing from the cathode, they can go for the other side. From the anode, if there are particles, they will come to this side. So in order to see them, we use here a high voltage source. Next point. Why they are using low pressure? Remember, students, we are using gas here and we are using high current also. Just imagine when you supply here high voltage and high pressure, what will happen to the glass tube? If the pressure is higher inside the glass tube, what will happen? Make a cadenava, right? So the glass will break. In order to prevent from that one, they have reduced the pressure inside the glass. Can you understand? That's why they have this kind of attack. So making up it adjust pressure එක අපිට ඕන වෙනස් කරන්න පුළුවන්. තව ඇතුලේ තියෙන ඒවා ඔක්කොම pressure එක අපිට ඇදලා ගන්න පුළුවන් එළියට. If they want, they can make this one as what? Vacuum pump. හරි? එතකොට මේකේ pressure එක සෑහෙන අඩු කරනවා. So when they reducing the pressure, they can make sure that we are prevented from the breaking glass. That's why they have reduced the pressure. Now, can you understand why we are using here high voltage source and low pressure? High voltage source is to see the particles whether they are moving from cathode to anode to cathode. Right? We need high energy. High voltage high energy. So therefore, by applying that kind of energy, we can observe that part. The reason that we apply low pressure is by applying this kind of high energy, and if the pressure is also greater, what will happen? This glass can be broken. So in order to prevent from that one, we are maintaining the pressure less than 0.01. Got it? Anything else? What are the doubts you have? So what if we do the opposite, like giving high pressure and lower energy? Yes, that's also a good question. By applying low voltage and high pressure, nothing will happen. Again, the voltage එකක් දුන්නොත් නේ cathode එකේ ඉඳලා anode එකට මේ වගේ particles යන්නේ. Remember, students, from the gas medium, I told you that from the gas medium, it's difficult to pass the current electricity. Now අපි දැන් මෙහෙම ඉදිද්දී gas එකකින් current එක pass වෙන්නේ නැහැ. From the atmosphere, the current is not passing easily. So therefore, it need high voltage source. අර අකුණු ගහනවා වගේ තඩි එකක් වැදුනොත් එහෙම ඉතින් ආයේ වාතයෙන් නෙමෙයි කොහෙන් හරි යනවා. Right? නේ? When it is lightning, we know that. So one of you told me that when it is lightning, so that is high voltage, right? So when it is high voltage, it can pass current electricity. So what is the main conclusion is actually gas can pass the current electricity under specific conditions. What are the conditions? High voltage source and low pressure. Lightning වලදී වෙන්නේ මේක තමයි. High voltage එකක් තියෙනවා and low pressure එක low. පල්ලෙහාට එන්න පොඩ්ඩක් pressure එක වැඩි වෙනවා උඩට යද්දී pressure එක පොඩ්ඩක් අඩු. Can you understand? So therefore try to understand why we are using high voltage source here. The reason is we need to see that the gas is passing the current electricity. If you apply low voltage, what will happen? Nothing more. No radiations, no current. If you decrease the voltage, when you increase the pressure, nothing will happen. But when you increase the voltage, when you increase the pressure, current will pass. හැබැයි ඒක බලන්න අපි එතන ඉදීත් දන්නේ. Why? Glass එක කැල්ල මොන හරි නොත් එහෙම. දඩ බඩාස් ගාලා පුපුරලා ගියොත් එහෙම විනාශයි. So therefore we are going to reduce the pressure. Understood? So look at this one. How many things that they have thought before they conduct this experiment. මේ experiment එක කරන්න ගල ඒක කොච්චර දේවල් හිතලා තියෙනවද බලන්න. So that's why they are greater scientists. Still we honor them. that is the reason. Okay, right. What else you have as questions? Yeah. With the presence of low voltage, definitely no current. Sir, does the high voltage remove electrons? Yes, that's what happened. These cathode rays are, okay, I won't say that one, wait a minute. What is the purpose of the glass tube? So we are doing this experiment in glass tube, right? The reason is a glass tube is making this is actually preventing us from the explosion or anything, right? By reducing the pressure, we can confirm that. That's why we're using a glass tube, right? If not, we can't do this one without any medium. Huh? So does high voltage remove electrons which carry electricity? Is the reason used to high voltage? Yes, that is the reason. Won't heat be produced? Heat. Yes, heat will produce. Definitely. Because we know that this is electrical energy. This electrical energy can be converted into heat also. Definitely heat will produce. Right? Yes, the conclusion is current can pass through air under certain conditions. Not at all the time. Under certain conditions, they can pass the current electricity. Right, students, that is not the case here. Actually, the case here is, yeah, current can pass through the electricity. That's okay, right, fine. Now, I told you that the second scientist was J.J. Thomson. This guy was very curious about this radiations emitter. Actually, he was very eager than the others. William Crookes, Julius Plucker, Wilhelm Hitov. He was very curious about what is this green glow? Do we know it? What is this? What are the new things we have to learn about this cathode rays? He was very eager. He conducted few experiments on cathode rays, and finally we got a conclusion that cathode rays are none other than what? None other than what? And next we are going to discuss about the experiments conducted by J.J. Thomson. Cathode rays are none other than electrons. Yes. Cathode rays are none other than electrons. Yes, that's correct. Remember, students, cathode rays are none other than electrons. So that was found by J.J. Thomson. Understood? Wilhelm Hitov, Julius Plucker, Sir William Crookes, J.J. Thomson, all of them conducted experiment to identify whether current electricity can pass through the gas medium. That's it. So they achieved the goal. Okay, but J.J. Thomson found that what are these cathode rays? What are these radiations? Because of this passing current electricity, only these radiations emitted. right? When it is passing current electricity, that means we know that in O-level time, we know that in order to pass the current electricity, there should be a medium. Ions or electrons. Ions or electrons can pass the current electricity. In a circuit, what will happen? In a circuit, just imagine we have a circuit like this. We have a battery and we have connected this one into a light, a bulb. So it's glowing. Because of what? Passing current electricity. That means electrons are passing from here to here. From negative side, electrons are passing for this direction. Ne? Understood? So therefore, you can see that the current electricity passing because of the electrons. So from this metal also, some of the radiations emitted and they carry electricity. So what are these cathode rays? What are these cathode rays then? Electrons. But J.J. Thomson wanted to confirm this one perfectly 100% whether these are electrons. He conducted 3 main experiments and another experiment to find out E/M ratio. So using them, finally he got a conclusion that these cathode rays are none other than what? Electrons. So I told you this was an accident. Why it was an accident? The reason is they never thought that they would find electrons here. Their intention was to find out the whether the current electricity passing through the gas medium. That's all. But finally, what happened? They found that subatomic particles, electrons are there in matter also. Matter and energy relationship he also explained. Why? Michael Faraday found that the fundamental particle in energy is electron. Current electricity passed because of the electron. Here, J.J. Thomson found later that this from the cathode metal, the particles emitted from there is what? Electron, not the atoms. Electrons means they can carry the electricity. So how J.J. Thomson proved that one? Yes. At next, we are going to learn that. Right. Now, first of all, draw this diagram, everyone. Did you draw this one? No. Okay, right. Then we have to briefly explain this one in the tutorial. So therefore, if you have completed this diagram, let's write down a small paragraph briefly what I was explaining here. Right, okay. I'm going to erase this. Under the cathode ray experiment. So let's write down this paragraph quickly with me. It was difficult to pass current electricity through the air. Therefore, two metal electrodes, quickly with me, two metal electrodes were used in the presence of helium-like gas, helium-like gas at very low pressure. At very low pressure. You can write down here that pressure is less than 0.01 mercury millimeter. In a hard glass tube. In a hard glass tube. These two electrodes were connected. These two electrodes were connected to high voltage source. To high voltage source. That high voltage source is greater than what? 10 kilovolts. Then cathode produced with me right now, produced a stream of invisible. They are invisible because of that sensitive screen only. So we could see that one. A stream of invisible radiation. Although the rays could not be seen, their presence was detected by zinc sulfide coated fluorescent screen at anode side. These rays were known as cathode rays. These rays were known as cathode rays, as starting from the cathode. They are starting from the cathode. That's why they have given cathode rays. Right? I will highlight here some key points to remember. Right? The first key point is helium-like gas. And the next point is very low pressure. Right? Electrode was connected to high voltage source. The cathode ray produced invisible radiation. The radius could not be seen. Their presence was detected by zinc sulfide coated fluorescent screen. Highlight these terms. So when you attend for the chemistry class, always bring highlighters, color pens. When you fill the tutorial, use them. At anode side, these rays were known as what? Cathode rays. Especially highlight this one, cathode rays. Quickly complete the note. Quickly. Right. At the last point, okay. Sorry. Students, your tutorial should be perfect. Huh? Now, after today's class, I will upload my note. Right? Look at this one. Me. Last highlight කරන්න ඕන තැන් highlight කරගන්න, right? In this way, you have to highlight them, right? Draw the diagrams nicely in this way. Everything should be perfect. Huh? So the next diagrams that we are going to draw. ලස්සනට ඩියුට් එක තියාගන්න, right? For a chemistry like subject, you should have a proper theory knowledge. හරි? දැන් exam එක ලඟ වෙනකොට පොඩ්ඩක් theory එක අමතක වුණ ගමන් theory note නැත්තම් ඉතින් ඉවරයි. I'll send you a file also to put these tutorials. I'll send that one, the file together with the logarithm book. Right, okay. Are we done? Are we clear? Do you have any doubts? So in Master Academy, you are doing chemistry classes, right? Will you do Master Academy Colonna? My physical classes are ongoing. Some of you are asking my physical classes also. So my physical classes are ongoing in Nigambo, Teaching First Higher Educational Institute. Nigambo actually, the main road actually, you can see the institute in Koppara Junction, Koppara Handiya. And in Colombo, I'm doing classes in Vellavatta, Colombo 6, Master Academy. So these are two places, and I'm not doing classes in Master Academy Colonnava branch, only in the Vellavatta branch. Because of the tight time schedule, I couldn't start the classes in Colonnava. So I'm only doing in Vellavatta actually, right? I saw that in the address list, actually, there was few people very close to me. Mallam-Pitiya, Kolonnawa, Kithampawwa. I saw a few addresses, right? I saw all of you. If you are joining for the physical classes, my physical classes are on Vellavat, Colombo 6. And this side, Nigambu, my second home, right? Teaching first higher education history. Right. Okay. Now we know the cathode ray experiment. Do we? Do we know what is cathode ray experiment? Yes, right. So I'll show you small video clip that I saw in the YouTube, and you can get an idea about the experiment. That means a experimental setup, how that cathode ray tube is working, right? So let's watch that one quickly. First of all, watch that one, and then later. So will you teach about lightning in the upcoming lessons? Lightning, not in upcoming lessons, but separately I can teach you about lightning, right? Because now lightning is not something related to us. You will learn this one in physics. You have a lesson known as electrostatic fields. There only you will learn this one. But if you are interested, I can teach you, doesn't matter, right? Later. Right. So let's see that video. I'll share that. Give me a minute. Right. So first of all, watch this video.
There are no gases inside this glass tube. The only thing we have are two electrodes, one's called the cathode, the other's called the anode, and a fluorescent screen in the background. It's coated with some type of fluorescent material. When I turn the power supply on, we'll see a beam that causes that fluorescent screen to glow. Looks like a nice straight line, doesn't it? We call that a cathode ray because it emanates or begins at the cathode and shoots across over to the anode. J.J. Thomson was working with cathode rays. We really didn't understand what they were. I mean, we have electricity going in one side and coming out the other, but there's nothing inside to conduct it. It's a vacuum tube. So he decided to apply a magnetic field to this cathode ray, and he found something interesting. We apply one pole of the magnet to this beam and we'll see what it does, and then we'll flip it around and see what the other pole does. This is my favorite part. Can you see what's happening to that beam? What does it appear as though it's happening to it?
It's moving.
It's moving, it's being repelled, isn't it, by the magnet. When we flip the magnet around, and what do you think is going to happen this time? Well, if it's being attracted on one pole, see how it's being attracted there? Let me rotate it so the kids on this side of the room can see it. See how it's being attracted there? And then the other pole, do you see how it's being pushed down? What does that tell me about that beam? It has a what? It has a charge.
Right, okay. Did you see that video? So that is the cathode ray experiment. That is the cathode ray experimental setup. So you saw that a green color radiations are going. But behind that, did you see that white color screen? Did you see that one? Behind that green color glow, there was a white color screen. So that white color screen is what? Fluorescent screen, which is zinc sulfide coated one. If it is not there, can we see that cathode rays? Cathode rays are invisible. In the presence of that fluorescent screen only, we could see that radiations. That's why I told you, right? Cathode rays are not green color. We can see the green color of the cathode rays because of the fluorescent screen. Okay, right. Now, so in that video, so he said that J.J. Thomson was working on cathode rays. So shall we see what are the things actually he did on cathode rays? Mainly, I wish to discuss about 3 experiments conducted by J.J. Thomson. So these are the actually points that you will get question in the exam, right? If you are given questions, these are the points, right? So let's see. Let's move for the next topic. Experiments conducted by J.J. Thomson. I'll write down here JJT on cathode rays. Right? Number 1. So here we are going to discuss about the experiment. What is the observation that got by J.J. Thomson and what was the conclusion, right? The first one, he created an electrical field on the path of cathode rays. Cathode rays. Look at this one. This kind of a diagram. Sorry, cathode rays. Thank you. Now look at the diagram. Huh? Finally, we can summarize what we learned today, right? So can you remember what we learned today? Everything? Right. Look at this diagram. So this is the cathode ray tube. Huh? Here they are using anode very closer to the cathode in this way. Please draw the diagram with me, everyone. Students, remember why I'm drawing these things, why I'm letting you to draw these things, because you want to get clear idea, clear image about these things. Understood? If not just showing videos, just giving the diagrams in the tutorial doesn't work all the time. So therefore you have to draw and understand it, right? So that's why I'm expecting from you all. Therefore, please draw these things with me. Sorry. We can see that the anode that they have used here. So that means J.J. Thomson. J.J. Thomson has used an anode with a hole, right? So can you see the path of this cathode rays here? So through this hole, cathode rays are moving like this without any deviation, without any deflection. These cathode rays are nicely, smoothly, they are going in their path. But can you see that? So J.J. Thomson has kept an electrical field. That means two electrodes. We know that if we have a positively charged tip and the negatively charged tip, we know that this is acting as an electric field. So what happened was these cathode rays, look at that. Okay? These cathode rays were nicely going in a straight line. And suddenly, when they meet the electric field, these cathode rays deflected towards the positively charged metal plate, positive tip of the electric field. Okay, now just imagine you are J.J. Thomson. Then where are J.J. Thomson? Now, if you are J.J. Thomson, what is your conclusion? Let's see. If you are J.J. Thomson, what is the conclusion that you would make? These particles are moving towards the positively charged metal plate. What is your conclusion? Let's see. You can tell that one, all of you. Yes, Sajida correct. Amina correct. What about the others? Steny correct. Senutmi correct. Yes, yes. Very good, very good. Yes, that was the answer I was expecting. Right? So, he concluded that these particles are emitting from the cathode are negatively charged. What is the conclusion? What is the conclusion? Conclusion is cathode ray particles are negatively charged. Can you understand? So this is the conclusion from the first experiment conducted by J.J. Thomson. J.J. Thomson created an electric field on the path of the cathode rays, and he observed that these cathode rays are deflecting towards the positive tip of the electric field. Then what is the conclusion he got? The conclusion is cathode ray particles are negatively charged. Can you understand? See, this is the first thing. So this is also one of the proofs that cathode rays are none other than what? Electrons. But wait, we have to discuss more. Two more experiments conducted by J.J. Thomson. Can you understand? Right? What are the doubts you have in this experiment? Anything? Anything you want to ask? Always electrons move from negative to positive. Yes. Always electrons are moving from negative to positive. That's what happened. So what about the negative charge? Negative charge. Cathode is negatively charged, anode is positively charged here. In this electric field, we can see that electrode, this metal electrode is negatively charged, and this metal electrode is positively charged. Okay, and finally we got the conclusion that what? Cathode ray particles are negatively charged. That's all. So why the anode is kept closer to cathode? Yeah. So that is actually, I think they want to keep electric field here. If I keep the anode here, so this can be disturbed, right? It can be a disturb for this electric field. That's why they have got this one closer, and they have used here perforated anode. Perforated anode means at the middle of the anode we have a metal plate. In that metal plate we have a hole. So through that hole cathode rays are emitting. So in order to avoid the disturbance of this from this anode to electric field, they have kept this anode very closer to the cathode. Understood? That is the reason. So why is anode broken into two? No. Here anode is not broken into two. Just imagine we have a round plate, we have a hole in it, right? So therefore, in this way, the cathode rays are going in here. So that's why I put here in this way. If not, don't think that anode is actually two parts. That's wrong. Yeah, it's look like a donut. Yes. So why it is known as electric field? So the reason is we have what? Two positive and negatively charged electric field, two metal plates. Now, if you consider cathode and anode together, so that is also electric field. So here's what? Electric field. So that's why this in here also we can say that these cathodes are moving, cathode rays are moving towards the anode, right? Because this is positively charged, cathode rays are negatively charged. So here we can see a perfect deflection. That is straight, no? So here we can see a deflection. Easy. So is anode perforated to allow the cathode rays to pass through? Yes, that is the reason. It is perforated because cathode rays can move from that hole. So do we have to supply high voltage? Yes, of course, right? I didn't mention that one here because in the previous diagram I mentioned no. So we always remember every time these cathode rays are emitting because of that high voltage source. High voltage source maintaining the pressure, those conditions are compulsory. In this experiment also they coated with zinc sulfide. Yes, because we need to see the radiations. You can keep a screen to see that glow. Can you remember the video that I showed you? In that video also he is actually using a magnet. By using a magnet, what will happen to the cathode rays? The cathode rays are deflecting, changing the direction. Yeah, that's why I told you. Instead of electric field, we can use magnetic field. In the magnetic field, what will happen is cathode rays are perpendicular to the magnetic field. Yes, very good. I saw many good questions from you. I really appreciate that one. That means you are learning something from here. That's very good. So what else? What are the doubts you have, students? What else? Anything you want to ask? So what is the main difference seen when using a magnetic field and electric field? The main difference is in electric field we have a positive tip and negative tip. In magnetic field we have north pole and south pole, two directions. So we can't say that electrons are moving for the south pole or else north pole, but we can say that by observation, we can say that electrons are moving perpendicular to the magnetic field. You will learn this one. So it's very complicated to explain here this one. In physics, you have lesson known as magnetic field, Biot-Savart law and everything you have to learn there. And at that time, you will learn that how the electrons are moving, deflecting in the presence of magnetic field, how the positively charged particles are deflecting in the presence of magnetic field, those things. So remember, keep that in your mind. So in the next day also, we are learning that magnetic field. In the presence of magnetic field, electrons are, what will happen? Perpendicularly moving. Sir, in the previous setup, since the ray fell into the zinc-coated fluorescent screen, we saw a glow. But how are observing in this? In this, what we can do is, behind this glass tube, we put a screen. Just imagine we put a screen. Can you remember the video that I showed you? Behind the glass wall, we put a screen. ඒ කියන්නේ නිකන් හිතන්න glass tube එක තියෙනවා. ඒකට පිටිපස්සේ මොකක් හරි screen එකක් තියෙනවා. So that screen is, if the screen is fluorescent screen, we can see nicely the green color glow is emitting from cathode. එතකොට ලස්සනට බලා ගන්න පුළුවන්. Screen එක ලොකුයි නම්, if the screen is big, we can see it nicely. Can you understand? නිෆ්ලා නේ? Yeah. What else? I need more doubts. Avahand, if you have doubts, it's okay, fine. Time is 11, but it's okay. If you have doubts, ask me. How many things we learned today? Ne? Right. What is the substance main present in zinc sulfide which makes the rays visible? Rays visible. So zinc sulfide means zinc sulfide. So the main substance that radiation visible because of zinc. We are learning that zinc is actually 3D element. 3D elements means in the periodic table we have D block elements. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So these elements can show some colors in the presence of, they can absorb some radiations, they can emit some radiations to see, to emit some colors. So because of the zinc only, we can see that. Zinc sulfide, the compound is made by zinc sulfide, white color coating compound. Okay, so the main reason that glow appears because of the zinc. Anything else? Right, okay. Now, if you have any doubts, put your doubts in the chat box, right? Did you draw this diagram? Done. Right, students, so this is our first theory session. Now let's talk a bit quickly. First of all, raise your hand who understood everything that we learned today. Please raise your hand who understood everything that we learned today, quickly. Okay, good. Right, many people have got the idea about the session. Was the session effective? Yes. How is chemistry? Is it funny? Is it boring? කම්මැලි වගේද? Interesting. Okay, good. Right. Happy to hear. Chemistry is awesome, sir. Okay, right. Right, okay. Curious. Interesting. Okay, right. Good. Right. Okay, I know that actually. මේක ලොකුකමට කියනවා හිතන්න එපා. සාමාන්‍යයෙන් yes. Do you know that something like this? I love teaching chemistry, right? මම මේක හරි ආසාවෙන් කැමැත්තෙන් කරන්නේ. ඔයගොල්ලෝ දැක්කද මම පැය 3ක බ්‍රේක් එකක්වත් නැතුව දැන් පැය 3 මෙතන මම හිටගෙන පන්තිය කරා. මට ඒක දැනුනේවත් නැහැ. හරි. සාමාන්‍යයෙන් අර බඩගින්න තියෙනකොට අපි කන්නනේ හොයන්නේ. ඒකට මේකත් නිකන් අර බඩගින්න වගේ තමයි. ඒ කියන්නේ උගන්නනවා කියන එක නිකන් yes, it's coming. I need that one. How bad do you want it? මට මේක ගොඩක් ඕනේ. Right? So I don't know what I don't know. So this is very interesting, right? So later you also will find that this subject is very interesting. So learn this one from the beginning, right? So first thing, I want to give you a homework summary. All of you, I need you all of you to write down a summary by yourself and put that summary into the WhatsApp group. Understood? What is the homework? Write down the summary of today's session and put the summary in the WhatsApp group. Right? So doesn't matter whether it is 10 sentences also doesn't matter. I need a small summary of the today's session. So write down that summary and send that one to me. And the next thing is, from the next week onwards, you will have continuity test and the rim paper both. I will upload that one to the group. One more thing I want to remind you that. So I gave you 2 free sessions. So from the next month onward, so the academy told me that, our online academy told me that you all should do the payments. So in order to do the payments, you have to contact our Sandhuni class coordinator. I'll put her number here. Her number is actually Sandhuni. Oh, Sandhuni. Note 77 801 6686. Right? So this is actually our class coordinator number. Contact her and join for the class. And our class fees, monthly class fees, 3,600. So she will tell you how to do the payments and everything. And then she will make a group. So then that will be our official, right? So anyhow, I will upload this recording to our common group also, current group, and I will upload the tutorials also, this session also. Those are the things, right? So as soon as possible, if you can do that one now, please write down the summary and put that one into the WhatsApp group. And I need some kind of comment, right, about our session today. Whether it is good or bad, doesn't matter, anything. You put that one into the WhatsApp group, right? What is the payment for physical? Physical class payment, you can get to know about that one in the physical class, right? So this is about our online class. So those are the things I want to remind. Okay, so can you remember what is the homework summary, and put a comment about today's class in the WhatsApp group, all of you, right? So next week you will have the continuity test and the rim paper. That means I will upload that paper. We can do that paper as a homework, right? Okay, then if you don't have continuity test, means actually we are going some kind of small questions. We are doing some questions, that's all. It's not that much difficult, very easy papers, right? If we have time in the class, definitely we are going to discuss that. Understood? Right, okay. Then, if you don't have any doubts, bye-bye, have fun. Let's meet on the next class. Good night. God bless you for all of you.